Welcome back to the class on textile finishing. Let us see what we have done till last time. We learnt about the mechanism of imparting stiffness to the textile fabrics or any other textile for that matter. The chemistry of some of the stiffeners which can be used, some for a temporary finish, others relatively more permanent finish, and the application processes also we looked. Other than padding, we could see the coating and lamination can also be used as one of the application processes. And where do we use these different fabrics? Also we discussed a bit on this. Today we will try to highlight some of the requirements of soft finishing. That means instead of stiff we are now talking about soft. So, first we should understand why somebody would need a soft finish, what exactly is the soft finish, and maybe some of the chemistry which is required. We shall try to discuss this in today's lecture. So, important thing which you may notice is that most of the people prefer softer touch. You see, very few people, particularly in terms of garments, would like to have stiffer garment. It is very rare that people ask for stiffer garment, and this soft touch is related to what we call as a tactile comfort. So, it is more comfortable to wear softer material apparel to begin with compared to stiffer, and so it appears there is a need. Clothing for babies needs special care. They obviously have a tender skin, and so much more softer material is what somebody would like to use next to their skin. Towels, bed linen and other type of linen where drape becomes an important characteristic, the softness is something what people would prefer. So, that makes a case in a way that why should somebody go for a soft finish. In fact, as you may notice, you may have practically noticed that harsh feel is not a preferred choice. People, whether it is household textiles or it is apparel textiles, people will prefer softer feel. So, that in some way is the need of a user. So, from a user point of view, the touch becomes an important thing. So, every time you want to go and buy a fabric, the first thing that you do is touch, and you feel with your hand, is it softer or stiffer. So, hand is a beautiful equipment, shall we say, or a sensor which can very easily distinguish between very small forces, differences of forces and the resistances. So, some of the other terms which people may like to understand, if you want a good drape, stiffer material will not be able to give you the kind of drape that you want, or sometimes this is known as a fall. So, drapes and fall for curtains and other kind of upholstery may be very important. For wear aesthetics also, drape becomes an important attribute. So, these attributes, if these attributes which improve, they will improve whenever softness is imparted. So, you will have a better touch, nice feel, you would have better drape and fall of the fabrics. And so, it appears that we may like to actually impart soft finish. So, if somebody says that this actually is the unique selling point for softening, people like it and it must be done. So, very few people actually would want a stiffer finish, and therefore, in the finishing unit operations of the various types of unit operations in finishing, softening becomes an important finishing operation. So, if we say the same thing again, an important area of textile finishing, we would like to add, if possible, some of the chemicals which are called the softeners into the pad bath of the regular finish that you are doing. For example, if you are doing the crease resistant finishing, then we may like to add a softener if possible in the pad bath of the cross linking agent itself. But in case it is not possible, that you cannot add for various reasons, compatibility reasons or any other thing, then in that case it by itself will become a separate process. So, you will have to do it again and apply the softeners. So, what would be the mechanism for making it soft? Well, something to do with the bending modulus. Are we talking about again the bending modulus of a fiber or a yarn or fabric? What? So, if somebody says let us reduce the bending modulus of the fiber, that would mean that you are internally at intermolecular level wanting to change the morphology. For example, if people use plasticizers within polymer or fiber, it becomes softer, but that normally as far as textile finishing is concerned, we may not like to do. So, what we may like to do is reduce the bending modulus of a yarn without actually modifying the fiber, or a fabric again without modifying the bending modulus of any fiber. So, we are not really going to change the fiber properties, but we are interested in changing the fabric properties, that is the most important, and in case required yarn properties. So, how do we do this? How do we do this? It is the opposite of what we were doing for stiffening purposes. So, here we will reduce the friction. Friction we mentioned earlier also, there we were increasing the friction between fibers, friction between yarns, and that will lead to softening. Now, how do we reduce friction? Have you heard of lubricants? What do they do? Lubricants, you add, in any kind of gearing systems which are moving, you add lubricants. What are they? They are basically oils, fats and waxes. They reduce, they function. How do they function? They make a film all around a moving part, and it is the film which gets the shear force, and the metal or a plastic or other parts do not touch each other. So, it makes a film and keep them separated. So, this layer is the one which is responsible for reducing the material to material friction. Let us say ball bearings and the gears and other moving parts. And now similar thing we would like to do on the textile. So, what is the general chemistry we said? There could be basically oils, waxes and combination of various such chemicals which can make a very thin liquid film around the surfaces. So, if you look at the textile, we obviously may not be interested in exactly what we are doing, let us say in a machinery parts which are moving, but intent definitely is to reduce the friction. All right. Must remember now, friction is a surface property, it is not a bulk property, it is the surfaces which have frictions. Whatever happens inside the fiber, the material is very different story, and therefore, we must remember this is also in a finishing treatment which is going to alter the surface characteristics of the fibers or the yarns. So, this is where our goal will be. And if you look at general requirement in any case which was with otherwise also, we need an interesting part of any chemical that is going to act like a softener will be the hydrophobic entity. Hydrophobic, in some sense you can also say oleophilic, but in our terms we like to use another term which you may like to remember is a hydrophobe. So, whatever this chemical is, this chemical certainly should have some hydrophobe, that is something which does not generally require like water. So, it does not like water kind of stuff. So, how do we get them? Some of these compounds which are being used otherwise can also be used to impart softness in the fabric. And how do we do that? By reducing the friction, by reducing surface friction, surface to surface friction. Essentially, all these are long chain fatty compounds or hydrocarbons, C16, C15, 17 type of hydrocarbons which are going to be used for such purposes. But then when we look at fabrics, we may like to have different requirements. A normal oil which is lying here and there, you can feel the smell, depends on what has happened, which oil we are talking about and how much has been used, the smell. I do not think people would like to have any kind of a odor coming out of their textile just because they have used some softener, which is also a hydrocarbon or a fatty compound. And so, this may be an interesting part which we will like to say we will not like. Normal oils may get rancid and start smelling, that is by the normal process of degradation. So, key point for this is hydrophobicity. Yes, this is important. Hydrophobicity will be an important component of this whole softening business. All the molecules that we will talk about will have hydrophobicity, yes, but it is important to note that hydrophobes are not water soluble. So, if something is not water soluble, how would you like to use it? You can say, well, we can use solvents, but solvent processing is not a very preferred method. People will like to prefer aqueous systems, water based recipes and formulations. That is what people like, and therefore, when you say these hydrophobes are not water soluble because they are called hydrophobes, so how do we use them? We would obviously be interested in ease of application. So, if they are not water soluble, then the ease of application may not be there. So, when you do a solvent based processing, then you will have to recover the solvent, the cost of recovering the solvent and any other dangers that are also involved will also have to be taken care of. And therefore, the chemistry of the softener may differ from a normal lubricant. For a normal lubricant which is used in machine parts, as we said, are basically hydrophobic compounds, oleophilic compounds, but for textiles we will have to change the chemistry a bit. So, before we look at some of the examples of softeners that have been suggested for textiles, let us say as a user, what will be the requirements, demand of a user. So, one of the demand, now this user I am not talking about the user who is wearing the fabrics or the garments, but the person who is going to apply also is a user in some sense. So, you may look into what they call as compatibility. Compatibility means when you add, as I said, it is quite possible that a large number of softeners you may like to use them along with the main finishing operation. You can, as I said, do it separate finishing treatment as well, but you may like to use them along with whatever is going on. In that sense, the compatibility with whatever other chemicals are there will have to be checked, and which will be not same because you are using different types of chemicals, and so compatibility will have to be obviously checked. In case we are combining or otherwise also, we may like to look at their stability at higher temperatures. Let us say you are doing a pat dry cure operation along with the softener, which by itself may not be reacting, but it has to withstand that temperature. If that is true, then we will have to look at the temperature stability as well. It has been seen that some of the chemicals by themselves, the stability related issue, thermal stability, but they do have a tendency with time also to get a bit yellow. So, yellowing could be tolerated if you are looking at a dark shade fabric garment, but if you are processing white or pale shade, very pale shade, then yellowing may not be a preferred thing, particularly definitely not for the whites. This is also a part of, in a way, a long term compatibility issue. It should not change the shade or the fastness, whether it is a light fastness or the other fastness properties. It should not affect the fastness property of the light, the dyed material. If that happens, then obviously it is not a good idea to have such type of chemical. Some more properties. It is interesting that most of these materials may have a tendency to foam. So, one will have to see they should not foam too much, because if they do foaming, and unless it is a foam finishing, where of course we want a foam, all other things are non-foam, low viscosity application systems, and there we would not like things to just keep foaming. Yes, this of course anybody can say that it should not be a chemical which is toxic in any manner, and so that somebody has to certify. Today, everything that we use, we would like to question, is it biodegradable or not? Because at the end of a life cycle, the products will have to be disposed in one way or the other, and so people will like to know whether this compound is biodegradable or how much. Well, this is again related to environment, the green chemistry. Green chemistry means that not just the application, but even manufacture and later disposal, all of them would come into the part. So, biodegradability is important, the green chemistry, that how much energy you have spent and how much pollution you have created while you were synthesizing this compound also may have to be checked. Emulsion. So, as I said, they are hydrophobic compounds, all right, and therefore, it is possible that you may have to make an emulsion out of them to apply. So, compounds which are not water soluble will have to be, but they are useful otherwise as a softener, we may have to go for emulsions. When you make emulsion, then you have to talk about stability of emulsion. It should not happen that you make an emulsion today and after 2 days you find that the emulsion has broken down, and which will not be a good idea at all. So, we want to know something which is interesting for us. Softening treatment of the textiles, is this a bulk property change or a surface property? The bulk property or a surface property? So, you must remember, we are not intending to change any bulk property of the fiber. Therefore, we are only interested in surface. So, we modify only surface. So, just a point to note forever that softening is a surface treatment. Although for durability purposes you may like it to react, you may like it to diffuse, but you obviously are not measuring or not in any way concerned about what happens to the bulk. As long as it does not get degraded, you are all right. Surface is what it must be changed. So, based on the chemistry of the hydrofoil, what is this hydrofoil coming from? So, if we represent a hydrofoil as a long chain, of so, we said hydrophobe is an important component element of a softener, and we also said that this is not water soluble by name itself and the character also. So, what do? We add a hydrofoil. A hydrofoil is the component which likes water. So, imagine now, although our purpose is going to be served of reducing the friction by the hydrophobe, but to make it, let us say, applicable through aqueous system, these compounds are attached with a water loving group, and that way you can make them water soluble. Therefore, you can apply through aqueous medium. So, hydrophile is important, is that right? So, based on the nature of the hydrophile, the softeners can be considered as anionic softeners, cationic softeners, amphoteric softeners or non-ionic softeners, right. So, this is an important thing. So, you have a long chain connected with some hydrophile. Do you remember something? What kind of compound these could be? So, you have an anion attached, then it will be anionic. If it is a cation attached, then it will be cationic. Amphoteric obviously means that the same molecule has a possibility of having a positive and a negative ion. So, ionic compound, these are ionic compounds and therefore, their water solubility is high. Of course, the solubility will depend upon the length of this chain as well, but if you do not have this, then they are not water soluble. So, that is the chemistry, and based on this their thing. Of course, in some cases we may prefer to have only non-ionics, but still we like to have a hydrophile which is water loving, but is not ionic, right. So, this is how we look into it. So, now we understand why hydrophile, otherwise they will not be water soluble. Okay. To make them water soluble, you will attach a hydrophile to a hydrophobe. So, these are therefore hydrophilic softeners in some sense, right, hydrophilic softeners. They like water, but we know what it is, a long fatty chain attached with a hydrophile. Okay. So, the question that was there which can be asked now, whether they will reduce the surface tension of water, whether these type of agents which we call as a hydrophilic softeners, which have a hydrophobe and a hydrophile, will these reduce the surface tension of water? Yes, they will. They are almost like anything which we called as surface active agents. They do come in some sense in the category of surface active agents, because they also have a hydrophobe and a hydrophile. So, this is again a recall, maybe you have learned somewhere at some time. So, these are surface active agents, and surface active agents also have a hydrophobe and hydrophile. They reduce the surface tension. And how do they reduce the surface tension? A surface active agent, how does it reduce the surface tension? So, let us say this was our molecule which has got the hydrophilic part here and a hydrophobic part here. So, if you put it in water, so the moment you put this in water, the hydrophobic part will like to come to the surface, because this part does not like, this part does not like the water. So, it wants to get out of water, right. So, they are therefore surface active. If there are so many of them, all of them will like to come to the surface, and in some sense they have changed the interface energy or tension of the water, and this is how they can reduce the surface tension. Normally, because of surface tension, the water would have the meniscus of this type. Okay. But in a way, these molecules are going to push this film or the interface outside, towards the outside. So, that is how they reduce the surface tension, and these softeners also will do the same thing. Okay. Will they demonstrate micelle formation? What is a micelle formation? A micelle formation is when there is no space left for them to rush out, then what do they do? Then they will have to, as there is an additional, you kept on increasing the concentration, then this molecule does not know what to do. So, if that condition comes, this part loves water, this part love water, but this part does not. So, in some sense there will be a hydrophobic interaction, and the hydrophobic part may like to come near each other and help in the formation of what is known as a micelle, because you have increased the concentration. There is no surface available through which they could satisfy their energy levels, and therefore, they will make micelles. Now, these micelles could be spherical, lamellar, all those things are there, but they would definitely, and this obviously is why it is thermodynamically more satisfying. Therefore, you will form a micelle. So, in our case, which is a softener, something like this you can expect whenever the concentrations are going to increase in solution. So, they also have what we define as a critical micelle concentration. If you plot concentration of a surfactant, or in our case it could be our own softener, and measure surface tension, so as we said, surface tension will reduce, it reduces, but after some time it cannot reduce further. That is the concentration where the micelles will start forming. Therefore, it is called the critical micelle concentration. They are not bad. Micelle formation by any means is not bad, it is okay, as long as we know how to handle, because this bonding is not a very strong bond, it is just an arrangement, because there was too much of water all around and only some part of the molecule likes the water, and so you have this micelle formation, right. So, we can just in a way we are revising that something like this can happen. So, there is another class of softeners which does not depend on the hydrophile chemistry. The four which we looked into just before, dependent on the hydrophile chemistry, and therefore they were classified accordingly. Now, they do not believe that they should be soluble in water. So, if they are not soluble in water, then what happens? So, some of the compounds that we look at are siloxanes, silicon based compounds, or polyethylene. Polyethylene also hydrocarbon, a long chain hydrocarbon. If you do not attach any hydrophile, it is not water soluble. So, what do? We apply them as emulsions. So, an emulsion is prepared in any aqueous system, and that emulsion is applied to whichever process, pat dry cure or any other process, that could be exhaust process, they are applied. Once they go onto the textile, then obviously the emulsion breaks, the water evaporates, and the compound stays onto the textile. How is emulsion formed? How is emulsion formed? The emulsion is formed by another surface active agents okay. They are also known as emulsifiers. And what are they? Yeah, they are also compounds which have got a hydrophobe and a hydrophile. Now, how this is helping? This will help if suppose you had water and you put oil droplets and mix them. So, you may get some oil droplets floating if you mix and at a high speed, for example. So, they will get mixed in some sense, they will be all over small oil particles. Keep it for some time and you will find that the oil is on the top and water is at the bottom. It separates. And so, what are we talking about then? We said the second class of softeners which do not rely on the hydrophile and its chemistry, they are not water soluble. So, they are oil soluble or they are oils by themselves. Okay. In such a case, an emulsion has to be made, and what does an emulsion do? Let us say this is an oil droplet created like this. So, oil droplet, the hydrophobe will love the oil droplet, they will go towards the oil droplet, and the outside will be hydrophiles of this emulsifier. Is that right? This is hydrophilic, which is outside. So, an oil droplet now is entrapped within the group of molecules. Now, this is in some sense a micelle which has entrapped the oil droplet. Now, this whole thing is as much stable in the whole water condition. So, you will have so many oil droplets which will be kept separated and thermodynamically satisfied by the use of emulsifiers, which are surface active agents, and so emulsion forms. So, once you form the emulsion, whether it is a silicon based system or it is polyethylene based emulsions, these can then be mixed into aqueous systems and can be applied. So, we have now two types. One type of a softeners are which are the hydrofoil is chemically attached to them, other is no hydrofoil, does not have any hydrofoil, but they can be emulsified and then applied. So, today for some time we will just spend some more time to look at some of the examples of anionic softeners. So, as far as the chemistry is concerned, the counter ion is an anion. Okay. What about solubility? Yes, they are water soluble. Because they are water soluble, so you have no problem as far as thing. Of course, in every system, as we have said, if they are water soluble, is because of the ionic nature, but if you keep on increasing the concentration, there will be a time when they will form micelle, and if you go further and further, they may not be able to be, they can just get out of the system, separate out, phase separate out. So, obviously, you have to, but generally it is a good solubility, that is why we added an anion. So, remember one thing, ionic compounds are water soluble, remember. Any time when you find a dye or thing, you add solubilizing groups and they are ionic. So, the simplest example could be if it is OH, which is the fatty salt, fatty acid, I am sorry, fatty acid is not going to be very much soluble, but the moment you convert this to a sodium salt, this will be water soluble, all right. So, solubility is here because of this hydrofoil, and the softening abilities come from this R, which is obviously a hydrocarbon. This R could be more than 12, but can go up to 17 carbon or 18 carbon units, and therefore, enough hydrophobicity will be there. So, the more is the length of the carbon chain, more hydrophobic it will become, right. So, generally 15, 16, 17 carbon units are good enough to be useful for softening. You remember the compound that we just discussed was almost like a normal soap. The soap, a fatty sodium salt of an acid, fatty acid. But there was a problem. What was the problem with them? The problem was hard water. Instead of sodium, if it becomes a calcium salt, then it would, or a magnesium salt, it would precipitate. And so, you require a softening treatment for the water, not just the textile. So, if you get a soft water, this works. So, therefore, some of the chemistry was changed of the hydrofoil. Instead of just having a sodium salt of an acid, you said if we make sulfates, then good amount of this hardness related problems can be tackled. And sodium salts of fatty compounds, sulfates would be something like this. So, again ionic, anionic, and therefore, R could be similarly the our normal hydrophobe, whatever length one chooses, accordingly its effects will be seen. Similarly, you can have compounds on sulfonates, which also you are familiar. So, again there is an anion here and R is a flexible hydrophobe. So simple. So, any type of R, if it is combined with one or the other hydrophile, it will become water soluble. This water solubility will ensure that it can be easily applied, and the R part, which is the hydrophobe, will do your work for doing the reducing the friction. So, theoretically in this category also there are many options are available. It is not just the 3 types. The R changes, the various kinds of chemicals and the acids can change, and one of the other interesting options people have been using is with the help of, let us say, a succinic acid. Succinic acid is simple. So, you got 2 carboxylic groups attached to a simple compound like CS2CS2. Sodium salts of succinates, sulfonic group is here, and there is a hydrophobe here, hydrophobe and a hydrophobe here, which you can term as R1 or R prime and R double prime, and this succinic acid has reacted with this hydrophobe in this manner. It is also interesting compound because this compound had the hydrophile in between 2 hydrophobes. So, it is a very different. So, some attachments and attraction etcetera are on in the middle of the compound, So, that is also interesting compound. So, people obviously have been looking at the possibilities of introducing many more types of compounds, but we are just looking at the some of the examples of the anionic type softening agents. Remember, we are not talking about water softening, we are talking about the fabric softeners, textile softeners. Last few comments for today. When we talk about compatibility, what type of chemicals are we looking at? This anionic compound, so you can be very sure if in the solution anything that you use which is cationic, then anionic softeners are out, you cannot use them, right. The hardness, sulfonates can tackle the hardness, but one would prefer when you are doing a thing, if the water is as less hard as possible, that will be a good idea. Although the fatty acids salts will have problem more than sulfonates. This is how the thing goes. Which fibers? Theoretically, as long as the chemical is able to go. So, you have an anionic dye, this is also anionic, compatibility issues are not there, aniting anything anionic, it will follow the same path as the dye, for example, will follow. Okay. So, you can add this in the same bath, the dyeing is happening, along with this also will get attached. However, if for example, you have a situation where the fibers have a positive charge, like in acidic medium any protein fiber would have a positive charge. So, they will have an affinity, more affinity to go towards them. So, this will be some binding taking place, all right. So, if any anionic dye or system is going in whichever way it is going, this can be added to the same bath. The exhaustion can also take place. Otherwise, pad dry cure process should not be a problem. So, a few more sentences on this bonding. So, we can expect if it is a cationic site on the fiber, it will be electrovalent bonding, salt linkage, but if it is like a direct dye going to a cotton and you also have a softener going to cotton, get exhausted. Once it gets exhausted, after that the bonding will be based on, let us say, van der Waals forces. The whole hydrophobe in a way would be, the molecule will be attached in some sense. It is a long molecule, diffusion may be not so easy, because a long molecule, but part of it will be obviously adhering to the surfaces, and the water solubility is there, but if that becomes an issue, durability can also be a thing. So, from bonding point of view, you are looking at basically generally for the main hydrophobe as van der Waals forces which can handle, get attached. How to apply? Well, exhaustion is definitely a possibility. Pad dry cure would never be a issue. If somebody asks, do we require curing to fix an anionic softener? Do we require curing? Normally, the kind of example that we have seen, you can understand, there is no covalent bonding happening with the softener here. But if your other process requires curing, let us say you have added the softener in cross-linking agent recipe, then the cross-linking agent requires curing. We only hope that this softener will not degrade during this process, that is all, but no other reaction will be possible. So, you can apply through any of these methods. Whenever you have time, you may be using soaps every day. So, you can see if different concentrations actually, when you do a pad dry or a soak dry, immerse, ring and dry versus no softener, that is even soap, as I am saying, could be a softener. So, check whether you get any softening effect by doing this simple exercise. So, what have we learned today? We have learned what is the need for softening. I think we are quite convinced, hopefully. The mechanism, which basically means reducing surface friction, right. Classification based on the hydrophile or non-hydrophilic material also. We just discussed a bit on the emulsion formation and the how surface active agents reduce surface tension and what is a critical micelle concentration, and we have seen some of the examples of anionic softeners. I think this is for today. Next time when we meet, we will talk about the other softeners, other types of softeners. Till then, thank you very much.